Alright, welcome back to another video on our node by node challenge where we're going through every single node within the shading workspace within Blender 4.3. So we've gone through all the inputs and outputs and colors, and now we're going through the converters. We've gone through most of the converters, but now we are on the one called vector math. So vector math is very similar to math. A lot of the functions are going to be identical. The only difference is it's going to have to do with 3 separated coordinates as opposed to just using the individual points that are in a math node. There's usually 2 inputs for a math node, and there are 3 for 2 different vectors on a vector math node, because you're basically combining the vector math of the one object, in this case our plane that I had basically just raised up in certain areas and lowered in other areas, and then the values that we set in the second half of the vector. So this would be useful if you want to change and offset whatever texture that you have on your object. So, and you can offset it, you can multiply it, you can do all kinds of things. I'm just going to show you some of them. I'm not going to go through every single one in vector math because there are a lot of them are very similar to using them within the regular math node, and a lot of these are ones that you will never ever use. There's some of them that are so rarely used there really isn't a whole lot of use for them, but they're in here just for, you know, future need and future use. I'm sure there's people that can use every single one of these, but most of the time you're not going to come across it. So we'll just go through a handful of them, and I'll just kind of show you what some of the ones that the other ones do that I'm not as familiar with, just so you can kind of see. So let's say we just had a Voronoi texture plugged into the principal BSDF. So in this case, it's just got the Voronoi mapped out on here based on the regular object. Okay, we're going to add in a texture coordinate and a vector math node here in a second, and you're going to see how this changes. So let's say that we change and we just plug in the vector math node with a texture coordinate in here, and now you're going to see that this is broken up into sections. So it's got big, large sections for each of these. Now you can still scale this and change this over, okay, to whatever size you want, and change the detail and everything, depending on what you're looking to do. But one thing that's cool is you can use this vector math. Now you'll see that there's all these different options in here. Like I said, we won't go through all of them. We'll go through a few of them here. So add is going to add and change the location along each of the axes. So you got the x-axis, the y-axis, the z is up and down. So if we were to add to this, you're going to see on the x-axis that this is moving, you know, upwards. Whereas if you go negative, it'll actually move the other direction. So that allows you, so if you have a texture and you really want to move it from one direction to the other, you can use this to offset it along the x-axis. You can do the same thing on the y. So a little hard to see when I go fast, but when you look at it that way, basically you're moving it left and right here. Okay. Now the z is going to kind of randomly move it around, so it's not going to be, you know, left and right or straight up and down. You kind of see it going at like an angle, almost like it's up and down. It's like it's rotating from around. Let's say that this was like a sphere. It'd almost be like it was rotating around the sphere because it's going from top to bottom. Okay, so that's add. If you do subtract, it's going to do the same thing, just it's going to go in the opposite direction. Okay, so depending on what you're doing, you can do the same thing with subtract for any of the axes as well. Then you have multiply. Now multiply, if you noticed, look what it did. It took for a handful of them and then made it into a lot more. And that's because you're multiplying this and increasing the number of the Voronoi and stretching it out. So look at it. If you want to do it this way where it's almost straight lines, you know, you can have it a really low number. The more you do, the more scrunched up it gets. So it's more like scaling it up and down. Same thing with the y-axis. And then z, because of the scaling up and down, it really wouldn't have anything. It doesn't change anything. Now divide works the same way but opposite, so it's going to scrunch it up towards the top, or stretch it out towards the bottom. Same thing along the y-axis. And the z does nothing again on this one. Multiply add is going to do both functions. It's going to use multiplication, but it's also going to use addition with it. So that means that it's going to take and multiply this to add more, and then add numbers to it. So if, let's say that the multiply wasn't getting exactly where you wanted to, you could actually multiply it, get it close, and then add to get where you need to be. So that's when that can be useful. Next, you're going to have cross product. So cross product, you'll see, is going to add more in both directions. Okay, and depending on what you want to do, it's going to have, it's basically almost like exponential, because it's going to give so many more based on the number you use. And Z has a huge impact, as you can see, because it's going to scrunch it up. It's basically making it super, super dense with all these different pixels. So it's a cool way you can add that in. Then you've got project. Project is going to be a little bit different, because if you notice, it's going to basically make these bars across the thing, the screen. It's projecting it onto the UV. If you change the Y, it rotates it around and makes it onto the Y-axis. And you can flip that around almost like it's going in a circle. The Z is going to keep it kind of scrunched up where it's at, top to bottom. Okay, so you can move those to change the direction and also the how tightly those lines are packed together. You've got reflect, which if you notice almost works like a mirror. So it's going to basically kind of morph in and out of itself. So this could be really cool if you have a texture, especially if you're animating a texture, that you can use this as a moving target to be able to morph from one thing to another. Reflect is a really, really cool one you can do, and it's got both along the x-axis, the y-axis. Z comes from underneath, so it's almost like it's rotating around, like I said, if it was a ball. Okay, you've got refract, which if you notice, refract is only going to basically have like a fanning effect. So if you look, it's almost like a fan opening up over itself, like unrolling. Like imagine that this was all folded up together and you were unrolling it. That's kind of the effect that it has as you move along each of these axes. Okay. And then this one has an IOR. The IOR is going to control more of the size and where the location is. Because if you notice, if you go too far, like negative over here, it's going to basically make it all purple. You go too far to the right, it also makes it purple. So it's really just in this middle area where it's kind of unwrapping itself. Next, you have face forward. So face forward is going to, as you can tell, have very little impact on it. Now, if you want to be able to have more change with it, you use more of a 3D object. It would work a little bit better. But this one, you can tell that if you go positive, it's going to go one direction, negative, it goes another. Okay, along the x-axis. But it has really no bearing on the y and the z. At least not for the incident. Does the same thing on reference. Positive to negative on both sides. Is going to shift it along the x and the y-axis. Dot product. Dot product is going to make it almost like the Voronoi that we originally had before we added in the vector map. The vector. But it's going to give it kind of not only a line effect, but also a fan effect too. If you notice this, it's almost like a pendulum swinging. And it depends on where the anchor is. So if you notice, the anchor on this one is at the top left line. Anchor on this one is going to be the bottom left line. And then the Z has no effect on it. Then you can go through the distance. So distance is going to give you the bars again, but the difference is it's going to kind of have a slow wave down this direction. So it's going to it's going to slightly turn as it's going around. So if you notice, it's basically like it circles its way around. And if you do the y-axis, it goes in the opposite direction. Z-axis goes left to upper right. So that's going to move it depending on, you know, your target of what you're trying to do. Then you've got length. If you notice, length is almost like ripples. So it's going to give like a rippled effect here, but it does not have any sliders. So this is more of a set pattern that you're going to have. Scale is just going to give you the original Voronoi, but it's going to allow you to scale it. It's going to allow you to scale it based on what you want, how many or how little that you want on here. Okay. Normalize gives a starting point, almost like sun rays coming off. But once again, it's a set pattern that you can't change. Absolute's going to make everything positive. So whether there's negative or positive numbers, they're all going to be just the absolute number. So it's not going to have anything negative or lack of color or texture in this case. Then you have minimum and maximum. Minimum is going to be based on the minimum range. So think of a range of numbers. Minimum is always going to be the bottom of the range, whereas maximum is always going to be the top of the range. And if you notice the difference, it's going to have them bars going either left to right or up and down. And they can be adjusted based on the axis that you want to use. You got floor. So floor is always going to be, if there's a range, and floor is always going to be the bottom of the floor, or the bottom of that range. Okay, in this case, the bottom of that range is purple. And you'll have ceiling, which is the opposite, which is the top of whatever that range is. So whatever numbers are plugged into here, it's going to take the top of that range from that vector. You've got fraction, which is basically going to take one divided by the other one. So it's going to give you a fraction or a partial number to create the texture on here, which just looks almost like a normal Voronoi. Modulo is the remainder. So it's basically if you had two numbers and one divided into the other one, whatever excess there is beyond the actual division. So like, for example, if you had 10 going into 15, so it's going to go into 15 once, and then it's going to have a remainder of 5. So 5 would be the remainder of the modulo. So that is where this comes in. So that's why you're going to have a little bit more of a harsh transition. If you notice, it's got like big division between the changes on here. Okay, and it's mainly in just the x-axis that you're going to see those changes. You've got wrap, where wrap, what it does is that you have a range. So this, whatever the range is, so let's say the range is 1.2 to 3.2. What that's going to do is it's going to say anytime that it's within that range, it's going to output that number or that value. And if it's outside the range, it wraps around, so it starts back out the same number. So if the range is 1.2 to 1.8 and the number gets to 1.9, instead of it being at 1.9, it will get back to 1.2 because it's going to wrap around. The number's going to wrap around, so it's going to continually circle around itself. Okay, and you'll see that it gets some pretty weird patterns, kind of another fanning effect a little bit. Then you've got snap. So snap is always going to snap to whatever increment you have. So these are all different increments that you've got. So like, for example, if you had a increment of 0.6, this is going to snap to the nearest 0.6. Okay, so it's going to be, in this case, if the number came out at 0.7, it actually would get snapped back to 0.6 because it's going to go to whatever the increment is. And it allows you to have a little bit of control of that. So you want to kind of have like a checkerboard effect. You could do that. And the numbers usually are going to start out a little bit on the lower side. So Z has no impact. X and Y are going to create that checkerboard effect. And then these last three. So these are all the the more complicated math structures, really the only thing you need to know is that sine is basically going to be like a roller coaster, to where it's going to start at 0, go up to 1, down to -1, back to 0, up to +1, down to 0, down to -1, and just kind of keeps rotating through. So the only advantage of that is that it's going to basically keep a float value between 1 and -1. So there are some uses for it, not a lot, but there are some uses out there depending on what you're doing. You can also do cosine. Cosine is going to be kind of more the opposite of that, for as far as how it's going to multiply, or sorry, as far as how it's going to rotate through. So from negative to positive and vice versa. And then tangent is going to be just sine divided by cosine. So there really is no use for this that I've seen so far. I haven't seen anybody use it or talk about it, but basically tangent, all it is sine divided by cosine. So there might be a use out there for it. I just haven't figured it out. So hopefully this makes sense and allows you to kind of understand a little bit. Most people, they'll just come in here and they'll flip through these until they get what they want. But at least this way it gives you a little bit of an idea, so you know somewhere to start. So hopefully that helps. That is the vector math node, and like, follow, share, and stay tuned for the next one.